All right. So I can give you a little bit of an overview as to what this unit is going to be about and what are some of the topics that we're going to talk about, right? Like what are we going to do, right? Well, statistics, right? It's all about collection of data, right? So basically, data is information, right? And it's usually in the form of some sort of values, right? So it could be the height, it could be scores, it could be IQ, it could be um, when like the number of devices students have, anything, right? Number of things, right? That is data, right? Data can be anything really. It could be money, right? Uh, I will add that actually, right? Money, like if somebody wants to keep track of the salaries of families and like what's the income that we have amongst different families in a certain community or country or province, whatever, you can do that, right? So everything has to do with data in this unit, right? And so that will always be specified by the question. Like, what are we talking about? Oh, we're talking about height of trees in a certain area, right? So we're always going to try to organize, analyze, and we're also going to compare, right? We're going to compare data points because that's where statistics is really helpful when you're trying to compare. For example, I always have, this is my go-to example, right? Like you and your friend, you're both taking applied math. You might have different teachers. So sometimes, hey, I got an 80 on this test on the trig. Oh, I just got a 60. You cannot automatically say that because you got an 80, you did better than the 60 because they're in different classes. So we need to do something within each class, come up with some sort of way to kind of put them all, because you're not comparing apples to apples, right? They're different classes, different teachers, different difficulty level, all of that. So you need to bring that back and normalize it, right? So that you can actually compare and see what's happening here, right? So from the data, from the, this is our, what everything revolves around, you have what we call MCTs, right? And those are measures, right? I hope you're copying this, measures of central tendency, right? And there you have your mean. I call them the three M's, right? Mean, which is, mean is also known as the average. What's the mean score for the class? What's the average score for the class? So there's mean, median, and mode, right? So the MCTs, the measures of central tendency, all three of these are trying to tell us where does the data kind of cluster around? Like where would the middle be, right? Where's the middle? So it's central, right? Center. So that's what the MCT. So we're going to use those to help us analyze data, right? Is data kind of, is it kind of clustered around the middle? Or if you look at all the data points, is it clustered towards one of the side or values, like the limits, the higher and the lower? Where is it, right? So that's what it's doing. And we're going to talk about dispersion, right? Dispersion, how spread out is it? How spread out is the data? That's what we're going to talk about as well. Okay. Um, from the data point, I'm going to zoom out a little bit because I want you to see the whole thing. We're going to try to have visual representations. The data, just a bunch of numbers on by themselves, is very hard to analyze and to see what's happening. With COVID cases, right? You go to the province's website and they give you all kinds of different graphs, right? So you can better understand what's happening. Some are line graphs, pie charts, you name it. That's what we want to do with data. We want to like put it in a graph so we can see what's happening, right? And so visual representations, we will have charts, we will have uh, uh, line graphs, bar graphs, and we have a, what's the other graph, the number line. That will change the names, but anyways. So those are some of the visual, we're gonna try to kind of put all the data points into a graph, right? We're also gonna talk about normal distribution. What is that? Normal distribution? Well, I want you to think of normal distribution. I want you to think of, whenever I say that or you hear it, is if you have your average, which is denoted by, or the mean, which is always x with a bar on top, okay? That's your average, that's the middle, normally. If you calculate the average, which we will do, right, we will actually be able to calculate that. If you were to plot the data points, you would end up having most of them around the mean, and then it would go down again, right? So let's talk COVID cases here because everybody understands that at this moment. If you would say that COVID cases, they tell you to isolate for 5 days now, right? With the Omicron, if you're vaccinated, 5 days after you get your symptoms. And so what are they doing here? They're basically, the province understands, the science shows that most of the time, right, most people after 5 days are done, like that. After that, they can no longer be contagious, right? So they're seeing that most of the time that's the case. Sure, there are some, as you move along, more days go by, there are some cases where even after 10 or 15 days they could be contagious, but it gets smaller. That probability goes less and less. Same with, if they said right, if there are fewer and fewer people that would only be contagious for 3 days or 2 days or 1 day, right? Most people are contagious for up to 5 days. So normal distribution, this data is, when it's normally distributed, if you were to graph it, it has a bell curve. So we can call this bell curve. Normal distribution, think bell curve, and that's what we want. And you remember, I know you've heard this many, many times, why did we go into a lockdown when COVID first started? Anybody know? What did they kept on saying, something about a curve? What did they want to do with the curve? In the chat, if you type that in. The hospitals can't flatten, there you go, flatten the curve, right? The province wanted to flatten the curve. They wanted to, like, if the curve is too steep, that means that too many people are coming in at the same time. They can't handle it. So they want to flatten the curve to kind of make it almost like a line if they can, or just a little bump, right? They don't want a steep curve. So that all has to do with what I'm just talking about here as well. So I want you to think of normal distribution, right? And I also want you to think of, this is a big one, standard deviation. And remember, everything is connected. Okay, everything I'm talking about here is connected. Graphs connect to, you can get a normal distribution, you can get a bell curve if you graph it, right? But then we identify, oh yeah, that looks like a normal distribution, right? Standard deviation is how spread, right? Measures how spread out data is. Standard deviation, write that down. And the symbol for standard deviation, write this down as well. I'm going to do that right on top here. It's almost like a theta, but the squiggle is more at the top like that. Stands for, that's standard deviation symbol. And the average, right? The average here, watch down here by the bell curve, X bar, and you'll see me doing that over and over again, so you don't have to panic too much about symbols right now, but it does happen. Okay, so look at what we have so far. Data is in the center. We have the measures of central tendency. We want to talk about dispersion, meaning how spread out is the data. Oh, wait a minute. Standard deviation will tell us that numerically, not just by observation, but it's actually going to be a value, which we call standard deviation. And what else do we have? I think that's it for now. And now we're going to start with our notes, but I just wanted to have this there. So if you want to take a, if you have a phone on, if you want to take a quick snapshot, if you didn't quite get this, but that's what I wanted to do before I started, okay? Oh, somebody typed something in the chat. Oh, that was probably the flatten part. Yeah, flatten the curve. Okay, good. Here we go. Let's start with our notes. I'm going to zoom in. There we go. So statistics, what is it? It is the collection and analysis of data. Okay? And it is also statistics aims to interpret what the data is trying to say, basically. And you will notice that understanding data is so important, because if you don't, you come to the wrong conclusions. Like, for example, a lot of people were saying, right? And it doesn't matter which side of the vaccine you're at, but folks were saying, look, like most cases coming in are fully vaccinated people. So obviously the vaccine isn't working. But that fails to account for the fact that most people, right? At one point, let's say 100 people, 100% of our population, everybody was vaccinated at that point. Technically, all of the cases coming in would have been fully vaccinated, right? Like the more people are vaccinated, the higher of a percentage of fully vaccinated people will, will still contract COVID, because it's not 100% effective, right? So being able to analyze, right? But then you look at the ICU cases, right? There's very few fully vaccinated people are also in the ICU, right? So there is a bit of a, you need to make sure you understand how to interpret data, right? Okay, so let's go through an example here. example. Below are the daily high temperatures over a 12-day period in April. And everything is in degrees Celsius. So there's another data sample, right? It's an example of degrees Celsius. So let's say I gave you the following value. So sometimes it's a chart, sometimes it's just individually stated. So 5 and 5, 8, 9, 5, -2, 9, 7, 12, 2. April is kind of like a wacky month, right, for that. 4, 6, 8, 10, 12. I always count the numbers just to make sure I get it right. And so I'm going to walk you through finding the mean, median, and mode, right? So I will talk about the mean or average. It would be, this is the formula for it. So X bar, this is very different of what you're used to, but it's saying the same thing, okay? It is basically the sum, this is a letter, it stands for sigma, which is the sum of all the values. So you add up all your data points, and then you divide it by n, which stands for the number of values that you added, okay? So I will put a little arrow saying sum of data points, and here I will say total number of values. That's what the average is. That's the formula, so I will box this in. Okay, so you don't need to worry about the formula too much, but the standard deviation formula will look similar, and I want you to see the similarities and the differences. Okay, so here we go. To get the average, you would simply add up all of these values, and I don't think I have to show you that, right? So you would get, if you were to add up all those values, you get 79, including this -2 here, right? So you would go 5 plus 5 plus 8 and 9 and keep going plus -2, right? So you would use on your calculator, right? If you had that, you could go 5 plus -2 like that, right? So make sure, because that would give you 3, right? In this case, there's an example how you type that in. Anyways, you get 79, and then you divide it by the number of values used in the first place, and we get, if you do that, you get 6.58 degrees Celsius. Remember, usually there will be units attached to it. If not, you're free to just put down units, but we know that we're talking, on average, the daily high is 6.58 degrees Celsius. Okay, so that's the mean. Now, is that a very good representation of what actually happens on a day-to-day? Like, what do you make of the -2 there, right? The -2, and I'll talk about that later, is somewhat of what we call an outlier. It lies outside of what most days are like. So that's the first thing I want you to observe. There's an outlier there. But the 6.58 degrees Celsius may not tell you a whole lot by itself. But let's say we took the daily highs of any country in the south. So let's say Mexico, or south of us, let's say Mexico. You take any city in Mexico and you just get the same daily highs on the same days in April. What would you expect of the average there? Would that number be higher or lower than our average? And I'm sure all of you are saying, well, it would be higher, right? So the average sometimes helps you to kind of see which city or which country is warmer compared to the other. That's another reason why the average is good to calculate, right? That helps us to compare, right? All right, let's go median. We need to find the median. Median is the number in the set that will have half of data points above it and half below it. Okay, so that's what the median is, right? In other words, the middle number in the set. Now, I need to say this. Sometimes that number is actually a number that is part of the data set, and other times you have to calculate it, okay? And I'm sure most of you know when that happens, right? But here it is anyways. If it's an even set, right, what do? Take the average of the two middle values. So here's your example. First, just going to give you a small example. Oh, this is important. It has to be arranged. Let's make a note here. Arrange it, right? When you're dealing with median, you want to arrange your set. So you want to go from lowest to high. It could be ascending or descending. I will usually go ascending, right? From smallest to greatest. So here it is. So 2, 4, 5, 7, 8, and 10, let's say, right? So in this case, you have, right, 6 values. N is equal to 6 values, and that is even, right? So what you need to do here is, in this case, it's small enough to just count down, right? So we're going to determine that if we take these two values in the set and we find the average between those two, that number is going to split this in half, right? So basically what you do here is, to get the median, is 5 plus 7 divided by 2. Careful. Note, invisible brackets. Anytime you have something added in the numerator and then divided, you need to assume that they're invisible brackets like that. So this would be 5 plus 7 is 12, divided by 2 is 6. And remember, we don't have units on this case. Sorry, I just gave you a data set. So 6, that's the median, right? So 6 splits this data set straight in half. But remember, 6 is not technically part of the data set. It's just the value that will split it in half, where you have half of the values above it, half below it, right? So when you even set, you need to do that. odd set, just pick middle value. Later on, I will show you a trick with a calculator, so I'm not spending too much time on really big data sets. So here, let's say you have 2, 4, 5, 7, 8, right? N is equal to 5, which is odd. And then in that case, it's very easy to decide that this is your median, right? Because 2 are below it and 2 are above it. It has to be the same number of values on either side. So the median is 5 in this case. Okay. So let's find the median of the median of daily highs. Okay. Before you do that, you want to arrange it. And I want to teach you how to use your calculator with this. It'll just make things a lot easier. Grab your calculator, clear your screen. Let me just make this a little brighter here. There. I'll give you some time to go get your calculator. I should have told you that ahead of time. But when you have this, we're going to put all of these values, that the daily highs, the 12 numbers, into L1. So let's go ahead and press Stat. Remember how to do that, right? Stat, Edit. Go to the top of L2, hit Clear, Enter. Go to L1, to the top, hit Clear and Enter. And let's type in those 12 values that I gave you before. And I can have them right in front of me, so it's 5, 5, 8, 9, 5, -2, 9, 7, 12, 2, 9, and 10. And look, as I'm typing in that last number, right, if I hover over, highlight that last number, it's as the 12th number, so I'm good. I typed in 12 numbers, okay? This is a quick way to arrange a number set. So let's say you have 40 values and you want to quickly arrange them. You're with me? You got to press Stat. Once you entered everything, press Stat again. And it says options 2 and 3 give you a sort option. So you want to sort in ascending or you want to sort in descending. I'm always going to use sort A, ascending order. So go sort A, select that, and then tell it to arrange whatever is in L1. So you got to go second and then 1. Close brackets. When you hit enter, it says done, which means if you now were to go back to L1, it's all arranged. Okay? So that's what I'm going to do. Stat, edit, watch that. All arranged already. So I basically take this with me. That's normally what I do. I have it on the side here, and I just basically use the arrow, up and down arrows, and just write down. Okay, so -2, 2, 5, 5, 5. There's 3 5s there. And there's a 7. There's an 8. There are 3 9s. There's a 10 and a 12, and that's it. So all of this was done, right? Arranging it without, because the numbers get pretty big, right? And it's very time consuming if you do this in your head, right? Or just by looking, you might miss one. Type them in carefully, don't rush, don't do the texting, right? There's no autocorrect on this one. So you got to make sure to do that. So I will just say to arrange on the side here, to arrange, enter values into L1, or L2 for that matter. You could have, like, right, if you're doing homework and you're doing a bunch of columns and later you want to compare them, L1, L2, L3, you can use them all, right? And then select sort A, and then L1, right? You should put L1 or L2, right? And then enter, and then done, okay? And you can go back to the list and it will be arranged. Isn't that cool? I find it cool. And so you have it arranged, and now you need to ask the question, right? N is equal to 12. There are 12 values here. So you need to kind of find the middle. So I'm just going to count on each side. I'm going to go 1, 2, or you can go 1, 2, 3, 4, 5. Let's stop there. 1, 2, 3, 4, 5. I counted 5 from either end, so I'm left with these two, right? It's between these two values where the median is going to be found. So median is 7 plus 8. You can tell it's going to be 7.5, right? Degrees Celsius, because we're talking about daily highs now. So the median temperature is 7.5, where half or below half of the days it's going to be less than that, right? So another good way of doing that. Okay, then the mode. Data point that occurs most often. Okay. And so here you can have a bunch of cases, so I'll just walk you through them, right? So 2, 3, 4, 5, 6. So let's say you have a small data set that's every number appears only once. There'll be no mode because all of the data points appear the same number of times. If you had 2, 3, 3, 5, 6, in this case, the 3 appears twice, so 3 units is the mode. Okay? And there's only one mode. In this case, 2, 3, 3, 5, 5, let's say, I will actually write it like this. Mode would be 3 and 5. Because the 3 appears 2 times and the 5 appears 2 times. Okay? You could have multiple modes, just like I gave you here. You could have 3 modes, 4 modes. It depends on what's happening. But let's say you had this 2, 2, 3, 3, 5, 5. You're like, oh yeah, 3 modes, right? Some of you might be thinking, yeah, 2, 3, and 5 are my modes. The answer is no mode. Okay. One way of looking at it is every number appears same number of times. So if that happens, like if every single value appears twice or every single value appears 3 times, then you don't have a mode. Like you would have to have at least one number that doesn't appear as many times as the others, right? And then that's how it is. Okay. So what's the mode of daily highs? And the nice thing is when you have it arranged, I'm going to go use that to my advantage. When it's arranged, it's super easy to pick out the modes. And you can tell 5 and 9 are the ones. Okay? 5 and 9 both appear. So you would write it like this. Mode be 5 degrees Celsius and 9 degrees Celsius. So you're like, most of the days is going to be 5 or 9, right? Like that's what we just found out. Or that appears most often, okay? All right, I hope you're doing okay. You're able to follow along. And I'm starting a new piece of paper. Here we go, and this one isn't a measure of central tendency, but it's still part of a tool we use to analyze data, and it's called the range, and not an MCT, okay? The MCTs are the 3 M's, right? Mean, median, mode. Most frequent data entry. Sorry, no, that's the mode. The difference, I will just say this. Sorry. It is calculated by subtracting the smallest data point from the largest. So if you had to calculate it, that's how you would do it, okay? But this is what it tells us. A small range, right? A small range will indicate, right? Indicates that data is closer to the mean and we will put down the words consistent. Okay. In a large range, will indicate that data is spread out farther from the mean. And that will cause inconsistency. Inconsistent, right? You're not as consistent. So let's just put it this way, I'll give you an example so you can understand it a little bit. So I have let's say I have two grade 11 applied classes. And I will use some scrap paper here. I won't add that, but let's say you have a class with an average of 60%, and the range in that class is, if you took the highest and the lowest score, is 20%. Then I have another class where I got an average amongst all students of 70, but there the range is, let's say, 35%. Okay. What does the range tell me? Remember, the range is if you subtract the highest and the lowest score, right? What the difference is between the highest and the lowest. And so if you have an average of 60% and the range is only 20%, that means that there isn't a whole lot of different cases that are really far out. Like most of the students are scoring very close to that average that I'm after, right? Because the average was calculated using the same data as you're using for your range. The other class with a 70, it might look better. Oh, 70%, wow. But there's a bigger range. So there are students that are scoring significantly lower, and maybe some students that are scoring very high, but your data is spread out. So you might have everything in between. So your average is not really a good representation of what's actually like how well every student is doing in the class. The 60s class tells you that most students are probably close to 60, could be 55, could be 65, but you're closer to 70. The range is bigger, so you might have actually students that are in the 50s or 45, right? And it's not such a good, it's not a consistent um, outcome there. Okay, so the range tells us that. So range of daily highs, and we're going back to the other one where having arranged everything helps us greatly, because I can just go back to that piece of paper where I wrote down the arranged points, and the highest is 12, the lowest is -2. So I'll just go range is 12 minus, and it's -2, right? That's the lowest, so double negative, watch out for that, which is 12 plus 2, really, because these two negatives turn into a positive. So there's a range of 14 degrees Celsius for us, okay? I bet you if you go to Mexico or a warmer place, that range is probably going to be a little bit smaller, right? It's going to be, it doesn't get as cold out of nowhere, right? It's a bit more consistent, right? So the range would have been less there, okay? All right, let's keep going. So we're going to now use our calculator to do everything we just did here, okay? Using the TI-84 to find MCTs plus range. This is so everything I just did here can be done really quickly using your calculator, right? So I'll tell you here, enter data points into L1, and you do that by going stat and edit. Sort data points, and you go stat sort A, and you go L1, right, like that. And then third, calculate the average and median using, this is what you got to press, and I'll show you how to do this. Stat, calc, one variable stat. One variable stats. You know how to get there. We did stat calc and we used to do quadratic regression. We're similar, but we're not. We're sticking with that first option there. And then fourth, determine the mode or the modes by looking at L1, which is now sorted, right? I made you sort it. So if you follow these steps, and it's basically, I'm going to get you to do that over and over again. If you do that, then you see that it'll be very easy to find your mode there. And fifth, find the range by going largest minus the smallest. Okay, which is also going to be found by just looking at L1. So I'll walk you through it right now. Maybe. We're just gonna, because I want you to do the same thing, like actually go through these steps. I'm just looking if I can just quickly get you to use one of these charts that I've given you. Okay, open your booklets, or get your booklets, the worksheet booklets, and we're gonna use data on page 1 of booklet to determine mean, median, mode, and range. Okay, so then we have a brand new example, a bit of like more numbers, so you get to practice that right away. And what I'm going to do first and foremost, I'm going to go all the way to the top, hit clear, and delete all the numbers that are in my L1. Then I'm going to take this table. So if you don't have this booklet, look at the screen and you have it right there. And I tend to always go up and down, like start at the top, go down, then move over like this. But whatever works for you. So here we go. Type those all in, okay? Somebody scored 102 there. Two students scored 102%. Oh my goodness. I'm just going to double check. It shows that I have 25 values according to this. I'm just going to go. So this is 16 and this is 9. So 16 and 9, that's 25. So I have 25 values. I'll make a note of that, okay? Just in case you 25 values or scores, right? Because those, by the way, those numbers, those were scores in a particular class, okay? Okay, so we went through the steps of entering all the data points into L1. We're going to go ahead and sort this. I'll give you some time to enter it. So basically, by the end of today, I want you to know what mean, median, mode, and range, what are the definitions, and how do you calculate them using my TI-84, okay? Because we're going to need that skill moving forward. All right, so I'm gonna arrange this. So stat, sort A, enter. I happen to have stuff into L1, so I want to sort L1, right? And then hit enter. When it says done, just go back, stat, edit, and everything is arranged. Okay. What does step number 3 say? Calculate the average and the median using stat calc one variable stats. This is newer, okay, new to you. So follow my lead here, okay? I'm going to press stat. I want to calculate things. So I'm going to go to calc, and I'm going to pick, you're never going to use two variable stats, okay? It's always going to stay at one variable stat. So select that one. And you got to tell one variable statistics which column to use. So I'm going to say L1. So one variable stats, and you go L1 and hit enter. And watch what just happened. The average is 74.36%. Okay? The average is 74.36%. You should see that at the top of your screen. If you didn't get that, you probably entered one of the values wrong, or you entered one, you missed one, or whatever. So it's very important to make sure. Watch what it says here. This is what I want you to look for. N is 25. It confirms to us that indeed we have 25 values considered here, 25 scores. And this is cool here. So for now, just the first thing, and the number of values is 25. That's good to know. And then scroll down. What does it say there? If you scroll down, you should see median. So it actually calculated the median for us. Okay, so we're going to go comma. The median is 76%. The mode, you have to, this is by observation, so you have to figure that out. How would I find the mode? I would go stat, edit, go to that L1 and scroll through it and see which one appears most often. I don't see anything that sticks out just yet. Oh, there I see it. 84 showed up twice. I don't know if you can see that on your screens, but 84 shows up twice here, and 102 shows up twice. So we have two modes here. 84%, comma, 102%. So this, I'll put this under. This I calculated by going one variable stats. Okay. This is just by observation, right? Looking at L1 sorted. And now the range. I know 102 is the highest. I'm going to subtract the lowest score. So I go at my calculator, and I notice that if I go to the very first entry of the sorted list, it's 40, right? You can see it's 40. So I just subtract 40, and my range for this particular class is 62%, which is not very good. 62% range from the highest to the lowest. A lot of scores are in between, are falling in between. I, as a teacher, would like it to be much closer, right? I'll rather take a lower average, but most students are there. Why would you say that? Because then I know, okay, everybody's kind of here. What can I do to bring everybody up, right? Versus like if it's all spread out, you're like, okay, a couple really got it, right? The 102% in this case, and a lot of students did not get it, and everything in between. So there's inconsistency. What is it, right? What's happening here? And so it's harder to make a decision as to what needs to be done afterwards. Okay. All right. I'm almost done here. So if we now go to the back side of this, I just want to add a few things here. Note range tells us the dispersion of data points. If the range is greater, spread out. If the range is smaller, it's clustered. Clustered. Okay. So let's try to make a graph like this. If the range is really big, your curve would look more like this. Right, this is your average, let's say, because the average tries to find the middle. Yeah, we're good. If the range is small, that means that the difference between the highest and lowest is they're closer together. If this is your average, they're closer together. So this actually makes a over exaggerated big bell curve, right? Because the min and the max are closer together here. Here you have your min and max further apart. So it kind of stretches out, it flattens the curve. So a greater range, right? The bigger that number, the more spread out things is. Remember that. The bigger the range, the more spread out data is. So you'll have scores all along here versus here the scores can only be between the highest and the lowest, so most of them will fall closer to the average. Okay. Another here is outlier, a value in the set that is significantly different from the rest. It's usually the result of human error, or like sometimes it's just, I don't know, just like April is just a weird month, right? Where you have that minus. In Calgary, they have the Chinook where you can be in like January -20 and it goes to +5 the next day. Those are very anomalies, are not normal, okay? Here we go. Your homework is you go page 211 in the textbook, and I want you to do one B. So you're trying to find the mean, median, and mode. And I want you to do question 2 and question 3. Okay, and I will tell you this. If you look at your screen, page 211, 1B, because 1B tells you to find the mean, median, mode. So for example, don't write in my textbooks, but this is mine, like my personal copy, so I can do that. So for example, there's like housing prices here for 3 different years. You can put this in L1, you can put this in L2, and you can put this in L3, and you find the mean, median, mode for all of them. There might not be a mode, right? That's okay. and the range can also be found for every single one, and try to compare and see what does this tell me, like having now the mean and the range in particular, what do those two things tell me about the different years and the cities, okay? That's the third one. The second one, you're comparing two different geography tests, right? And so put this into L1 and find everything about it, like the mean, median, mode, and range for it. And this one you put into L2, so you're not erasing because you might have to go back and try it again, right? So putting stuff in different columns is very helpful. And then here, the first question, right, you can put this into L1 and daily highs and Windsor in L2. There's the bell. But make sure you try that to find the mean, median, mode, and the range, and then try to talk about what that means in each case. Any questions before I go? Type them in the chat right now if you have any questions. Our bell is off by a little bit before I go.